translating it into a radical expression. So I'm going to go ahead and work with the problems that were on your last quiz. So feel free to have your quiz out in front of you and double check your work to make sure that everything went correctly. So the first one that we're going to take a look at will be negative x to the fifth all over 32, and this is raised to the 4/5 power. What I want you to note is what I'm showing you in red. The negative sign, notice that it is all the way to the left of this expression. It's not located inside of the parentheses. So really what this means is that this negative over here is really just going to kind of be set to the side, and it will eventually tack itself on at the very end. Because if you think about your order of operations, you would take care of what you see inside the parentheses first, then you would take care of exponents, and this negative that you're seeing here is really a -1. So at the very end, since multiplication is the last step that we would do in order of operations in this case, we would multiply our final answer by a -1. So in order to do the full evaluation, again, that negative is going to be set to the side, and I'm going to translate this rational expression. Note that the denominator here is 5. So that means that I'm going to translate this to be the 5th root of x to the 5th over 32. And then the 4 here means that that expression will still be raised to the 4th power. Now we can go ahead and evaluate this. So again, we're going to set that equal. The negative is going to wait. And if you need to, we can break that 5th root so that it's the 5th root of x to the 5th over the 5th root of 32. Now we can go ahead and evaluate further. Again, that negative stays on the outside and just waits. It bides its time. So the 5th root of x to the 5th will just be x. So in other words, one group of 5 x's will be able to escape that 5th root. For 32, if you need to think about it, we can always break it down into its prime factorization. So for example, 32 could break down into 2 times 16. 2 is a prime number, so I'm going to circle it. 16 can break down into 2 times 8. And I'm going to cross off the 16 so I don't accidentally go ahead and use it. So I'm going to go ahead and break down the 8. So 2 and 4, 2, cancel out the 8 because I've decomposed it. And then the 4 becomes a 2 and a 2. And again, cross it off so you aren't tempted to use it again. Notice that you do have 5 2's, so one group of 5 2's can come out. Again, I'm going to say that one more time because I know there were a lot of numbers in that last sentence. One grouping of 5 2's can come out. So now what we can do is we can go ahead and continue to evaluate. So really what this means is that since I have x over 2 raised to the 4th power, the value that I have in the numerator will be raised to the 4th power, and the value in the denominator will also be raised to the 4th power. So again, this is equal to, now what we have is x to the 4th power over 2 to the 4th power, and then we can further evaluate that. Okay, so this is equal to negative, and finally x to the 4th, and 2 to the 4th power will give me 16. So my final answer will be negative x to the 4th over 16. So let's take a look at another problem very similar to it. Okay, so I'm going to scroll up. Okay, so the problem that we're going to go ahead and take a look at is going to be negative 27 over 64 y to the 6th, and this rational expression is going to be raised to the 2/3. Again, the negative that you're seeing here is really a -1 multiplying with that rational and exponential expression. Okay, so what we can do is, again, the negative is just going to kind of wait on the side, and we can go to work. All right. So again, let's take a look at the denominator of this exponent, and we note that it's 3. So that means that we can translate this into the cube root of 27 over 64 y to the 6th. What we also want to note is that we do have a 2. So once we are done taking that root, we're going to square the answer that we get out of that. Okay, again, the negative just drops down, and we're going to go ahead and evaluate. If you need to, you can change this into the cube root of 27 over the cube root of 64y to the 6th, and from there we can continue to evaluate. So, negative comes down, and we'll evaluate. So if we need to think about 27, 27 can break down into 9 times 3. 9 can break down into 3 times 3. And again, I'm going to cross out that 9 so I'm not tempted to go back to it and use it. So look, I have a group of 3, a group of 3 3's, which means that I would have 3 in the numerator. And if I work with 64, that breaks down into 8 times 8. That breaks down into 2 times 4 for each of them. There are 2 2's that are prime. The 4's can break down into 2 times 2 as well. So lo and behold, here's one group of 3 2's and 2 groups of 3 2's. So in other words, I can write 2 times 2 in the denominator, or I could just write 4. And then take a look at y to the 6th. How many groups of 3 y's do you have in there? And hopefully you're thinking, well, I have 2 of them. Okay, so finally, scroll that up a little bit so I have some space. Again, the negative comes down. Now I can go ahead and distribute that square to each of those terms. And this becomes negative, and then 3 squared is 9, 4 squared is 16, y squared squared, that is your power rule, that becomes y to the 4th. Okay, I hope this video was helpful.